Hello Internet! This video is about modeling furniture handles with Blender for 3D printing. This video is the first part of a small series on this topic. In the series I will use different modeling techniques and address important aspects for 3D printing and modeling with Blender. In addition, I would like to offer a recipe for a quick implementation of furniture handles using a 3D printer. In the first part we will work with the modeling based on primitives and mesh modeling. In the other parts of the series I will use curve-based modeling, primitives with Boolean operations and also non-destructive modeling techniques using the Blender modifiers. But enough of the words, let's see how we can model furniture handles for 3D printing. As a first step, we set up Blender for precise modeling of workpieces and define the measuring system to millimeters. For this purpose, the corresponding scaling factor of 0.001 is entered in the measurement unit settings. I set the overlay grid to the same size using the same scaling factor. Normally I work mainly in the orthogonal perspective for precise modeling. With the corresponding key combinations of the numeric keyboard like 7, 1, 3, we switch to the top and side views. If we use the Shift key in combination, we can work on the opposite views. In this example I use a base model and mesh modeling to create the furniture handle. I use a cube model as a base and set the exact dimensions with the transform dialog. To be more efficient, I will use the mirror modifier and model only one half of my workpiece. To do this, I will set the origin point of the model to a face and move the model to the origin point of the overall model view. Now I can add an empty object and use this as a reference for mirroring the model. Basically, it is a good idea to apply the scaling to all objects before modeling, especially for objects in relation with Blender modifiers. Strange effects in relation with the modifiers can often be traced back to not applied scaling or rotation, because these factors are used internally to calculate the geometry. Additionally, I work with the snap mode and use the grid pattern for absolute positioning. Now I start the modeling and select the face of the object to extract it. Keep in mind, if you switch to the orthogonal perspective and top view, you can use the grid snap function for easy positioning. To restrict the extraction to the x-axis, I use the EX key combination. Now I want to have a nice curve at the corner and therefore I create the necessary geometry using the spin tool. To define the radius with the cursor, I position the cursor and set the pivot point to the cursor mode. Now I delete the unnecessary geometry, mark the geometry for the spin tool and create the bend. Now we continue with the extrusion on the y-axis. Additionally, the scaling can be used. I activate the proportional fall-off function to get a uniformly rounded, thicker profile at the end. Since I want to apply the subdivision surface modifier later, I set an inset face at the end so the modifier does not round the entire geometry. For 3D printing with the FDM process, the fused deposition modeling, it is an advantage if the workpiece has no sharp corners, because it is much easier to print for the machine. At the same time, forces acting on the handle are better distributed and the result is a more stable furniture handle. In addition, it makes the surface treatment, for example painting and sanding, much easier. Therefore, I highly recommend to avoid sharp corners. To tighten the furniture handle, we can directly use wood screws or use a threaded insert. In both cases, we should strengthen the material for the thread. To do this, I cut out the cylinder with a Boolean modifier and prepare another cylinder with reinforced walls as an additional object using the Solidify modifier. Now I make sure that the object to be cut out protrudes a little. This makes it easier for the Boolean algorithm to cut out the object cleanly, although the new exact mode can handle overlapping faces. Using the Solidify modifier, I can use a negative thickness value. I will add this object later in Cura separately in the model and have it slide with 100% infill density. Also here I add the mirror modifier to the cylinder object, using the empty as the origin for the mirror operation. Now we can prepare the object for 3D printing or make further design decisions. We can use the subdivision surface modifier and round off the sharp edges a bit. To do this, set the subdivision surface modifier before the Boolean modifier, so that the geometry of the cutouts is not changed. The subdivision surface modifier reacts here in my model to an unnecessary face. This can be deleted. Important: merge should be activated in the mirror modifier to create a clean geometry. Another option is to enable the clipping, but it is not needed for this example. To limit the effects of the subdivision surface modifier, the model can be further divided using the loop cut tool. Then the new geometry can be adjusted as desired. It is best if you activate proportional editing for this, to make the transition smooth. Another alternative is the Bevel Modifier. Also in this example, I add the subdivision surface modifier and move it on top before the Boolean modifier. Then I delete the unnecessary face, and now I can add the Bevel Modifier. If you use the Bevel Modifier, you have to place the modifier before the subdivision surface modifier. You can play around with the different options to see the effects on your model. Again, you can use the proportional editing to get smooth transitions while you're changing the geometry of your model. Here I scale the selected faces on the Z-axis and use the proportional editing settings to get some smooth transitions to the remaining geometry. At this point, we can adjust the geometry with the mesh editing tools, or we can edit the model with the different modifiers. For example, we can use the smooth modifier, the lattice modifier, or the deform modifier to change the shape of our model. For this example, I choose to keep the profile as round as possible and used only the subdivision surface modifier. The modifier rounds out the overall object geometry, so complementary steps such as Boolean operations should be performed afterwards. In addition, I modified the final mesh using the mesh editing tools according to my requirements, and I had the proportional editing activated. At this point, it is important to keep track of the number of final vertices and faces. We want to prepare the model for 3D printing and should limit the number of vertices and faces as much as possible, so that the slicer software that we run later on can calculate the 3D printed model as easy as possible. This prevents time-consuming calculations in your slicer software and even crashes. As long as the modifiers are enabled and the final model is still applied, we can use the decimate modifier to show the number of faces. To see the effect of the decimate modifier better during modeling, I activate the matcap lightning in the viewport settings. Just add the decimate modifier at the end of your modifier list. Many details in our model geometry are not relevant for 3D printing. Due to the limited resolution in 3D printing, they are not needed. Maybe we have a slicing height, a layer height of 0.1 millimeters or 0.05 millimeters, which of course depends on the printing method and the printer itself. Many of the finer details are not visible in the final 3D printed object. We can also use the modifier to recalculate the geometry and reduce the number of faces. In the example, you can see very nicely how drastically changing the resolution in the subdivision modifier has an effect. With the remesh or decimate modifier, we often have the possibility to reduce the number of faces by 50% or more without having a visible effect on the final model. In this example, this is not necessary, but we will see in a future episode that the final revision of vertices must be applied before slicing for certain types of modeling. The model can be transferred to a mesh before slicing to find possible errors in the geometry, and also unnecessary vertices, overlapping vertices, and non-manifold sections in your geometry. In our example, this is not necessary because it's a very simple model and we can apply the modifiers during the export to STL format. Using the 3D Print toolbox and the mesh cleanup tools is a topic of its own, and I created a separate video for that. I will add a link here to this video.
Now let's export the model into STL format and hand it over to the slicing software. Because I did not apply the modifiers in before, I checked the Assign Modifiers checkbox. I think my export settings are pretty self-explanatory and therefore just follow the settings on the screen. If you have any questions, feel free to add them in the comment section. Well, I exported my 3D model and also the cylinder object for the screw and opened the STL files in my slicer software. Here I use Cura in the version 4.9. After the objects are imported into Cura, I started the slicing configuration. My goal is to get a result that is as robust or stable as possible. The furniture handle lies flat on the base plate, so I have a good position of the layers in relation to the forces acting on the handle. The layers have a large area where they stick together. If I place the handle upright, there is a great risk that the handle would break off since the overlapping area of the layers is small and the layer adhesion in the vertical direction is significantly lower compared to the cohesion of a layer in the horizontal plane. So now let's have a look to some further typical additional settings that I make to get a robust and stable result. First, a thick outer wall, at least with a thickness of 1.2 millimeters. Then an infill above 35 to 55%. A higher infill does not automatically mean that your workpiece is stronger. So normally an infill between 35 and 55% is a good value to get a really strong workpiece as a result. I add support structures where necessary and I configured a slightly increased printing temperature, let's say 2 to 3%, to improve the layer bonding during printing. Alternatively, cooling can be reduced slightly. In Cura it is possible to configure additional objects with their own slicing parameters. Therefore I position the screw cylinders and set the infill parameter to 100%. Because here I wanted to have enough material for the screws to hold. The result can be seen here. All other details can be taken from the video and of course dependent on the printer and the filament used. In my case I use a PLA Plus filament, which is printed at a higher temperature and achieves greater strength in the finished model, and it is a more robust and stronger material compared to normal PLA. That's it for today. I end the video with a few pictures of the first printed models and hope you have fun making it yourself. As I said it before, there will be 1 or 2 more videos on this topic, show different modeling techniques. Also in the next video I will attach the handles to some wooden components to see how it looks like, to see the result and outcome of our design decisions, but this is content of one of the upcoming videos. It would be great if you could like the video and if you like to subscribe. I would appreciate constructive feedback and it would be very interesting for me to know what you are thinking, how I can improve my models and also my videos. That's all for now. So have a good time. Thanks for watching. Bye, Friedhelm.